In this video, our goal is to solve 2 cosine squared theta minus 1 equals 0 graphically and symbolically for theta between 0 and 360 degrees. So to solve the equation graphically, the idea is to let y1 equal the left-hand side of the equation and let y2 be equal to the right-hand side of the equation, and then determine the points of intersection for those two graphs. So to do that, we're going to use the Desmos graphing calculator. In Desmos, I need to enter y as a function of x. So I'm going to enter y is equal to 2 cosine squared x minus 1. Then for y2, I'll enter y is equal to 0. Solutions between 0 degrees and 360 degrees. So I want to make sure that my calculator is in degree mode. So I'll go to settings. Right now it's in radian mode. I need to switch that to degrees. I want solutions from 0 to 360 degrees, so I'm going to change the x minimum to 0 and the x maximum to 360. And for the y-axis, I'm looking for where the y values are 0. I'm going to use a scale from -2 to 2 so that 0 is right in the middle. And I'll use an x scale of 15, since 15 divides evenly into all of our special angles. Now we have the graph. We need to determine where the two graphs intersect each other. We see that the first intersection point is at 45. The next one is at 135, 225, and 315. It appears that we have 4 solutions: 45, 135, 225, and 315 degrees. So to solve the equation graphically, we first of all sketched a graph of y1, the left-hand side of the equation, y2, the left-hand side of the equation, and then we determined where did the two graphs intersect each other. The first point of intersection was at 45 degrees. The second point of intersection was at 135 degrees. The next one at 225 degrees. And the last one at 315 degrees. So these are our 4 solutions. However, the problem also asks us to solve the problem symbolically. So let's go through that procedure. The first step will be to isolate cosine theta. So first of all, we'll add 1 to both sides of the equation. That will give us 2 cosine squared theta is equal to 1. The next step will be to divide both sides by 2. That will give us cosine squared theta is equal to 1/2. And then the last step will be to take the square root of both sides, and we'll get cosine of theta is equal to plus or minus the square root of 1/2. And that's the same as plus or minus the square root of 1, which is 1 over the square root of 2. And if we rationalize the denominator, multiplying by the square root of 2 over the square root of 2, we end up with plus or minus the square root of 2 over 2. Now hopefully you recognize that as one of our special values. The reference angle is 45 degrees. So I'll just write down reference angle is equal to 45 degrees. And we see that cosine is positive or negative. Cosine is positive in the first and the fourth quadrants, and negative in the second and the third quadrants. So what we want to do is to find each angle with a reference angle of 45 degrees in the first, second, third, and fourth quadrants. So our first solution will be equal to 45 degrees. Our second solution will be 180 degrees minus 45 degrees is equal to 135 degrees. Our third solution in the third quadrant will be 180 degrees plus 45 degrees, which is the 225 degrees. And then finally, our fourth solution will be equal to 360 degrees minus 45 degrees is equal to 315 degrees.